Find cosine inverse of -1. Okay, we seek a real number. We seek real number y, an element of the closed interval from 0 to pi. Okay, so we're going to draw that 0 to pi. 0 to pi. That's either quadrant 1 or quadrant 2. Shade those regions. That's where our y value has to live, either 1 or 2. Such that, so we seek this y, such that the cosine of the y is equal to a -1. Okay, so let's stop and think about this. -1. Before we go any further, let's stop. Where is cosine going to be negative? Negative in quadrant 1 or 2? Well, in quadrant 1, everybody's positive. Quadrant 2, only sine and cosecant are positive. Everybody else is negative, so it's going to be in quadrant 2. Keep that in mind. It's going to be between pi over 2 and pi. Okay, let's continue. Well, we can actually do a picture because of 1. 1 is an interesting number. We want the cosine inverse of -1. We'll do the cosine function, the wave function, from -1 to +1 on the y-axis, 0 to pi. We're only interested in 0 to pi here. So we're going to actually draw half of the cosine function because we're only interested in 0 to pi. Okay, so you see it's at 0, 1, then it's at pi over 2, 0, then it's at pi -1. Here we have quadrant 1 from 0 to pi over 2 and quadrant 2 from pi over 2 to pi. Okay, and you can see the values of the cosine function are below the x-axis from pi over 2 to pi. So it validates what we said earlier, that we have to be in the quadrant 2. So the cosine of pi we know is equal to -1 from this graph. Thus, the cosine inverse of -1 is equal to pi. Okay? And that's because the conditions were met. Pi was an element from 0 to pi, right? And that's a closed interval, so it can be pi itself. And the cosine of pi is equal to -1. It really was an easier problem than the others because we could just look at the wave graph that we drew and see exactly where this guy is equal to -1. On the restriction from 0 to pi, of course. We always have to consider the restricted domain.